need to do is you have this page, and what we're going to do is cut out these. So we're going to cut out these different shapes. So we're going to cut out the square, rectangle, trapezium, it's called, rhombus, trapezoid, parallelograms, and rectangles. So there's 7 different ones. And if you look up there, we're going to look through all the different shapes that we have and kind of show you how to go through that. Now, the first one that we're going to look at in the top left corner, this one right here is called a parallelogram. So that's going to go up here in the top left. So you'll want to paste that shape up there for parallelogram, and we'll make sure that it matches what you've already done. So we'll take parallelogram and go up there. Parallelogram just means you have 2 pairs of parallel sides. So if you notice, this right here and this right here are parallel, they go in the same direction. And then this here and this here are parallel, they're going in the same direction. So that's what makes that a parallelogram. It's 2 pairs of parallel sides. Right beside that, you see a trapezoid. That's the one you probably used to see in a thing like that. A trapezoid, it only has 1 pair of parallel sides. That means in a trapezoid, it means that these are not parallel. So these are kind of going in opposite directions. But the top and bottom is a pair of parallel sides. So that one's good for trapezoid. Then we get to that one over there. It says no parallel sides. It's called a trapezium, or it's really just a regular quadrilateral. It doesn't have any parallel sides. So like every single side is going in some different direction. And that's in the top right up here. So everything's going in different directions. The next one we get to, these are the ones that we're more familiar with here. We see the rectangle. So the rectangle is a parallelogram. So that means it is a parallelogram, just like it was here, with right angles. And for some reason on here, they've got rectangle twice. You only need it once. So if you notice that there were 7 boxes and only 6 things, that's why. So the rectangle is here. It is the parallelogram with right angles. Okay, next you see the rhombus. That's going to be right here. It is a parallelogram with congruent sides. Congruent sides means all 4 of these sides are the same. The only thing that doesn't make it a square is that it doesn't have the 4 right angles. So it does have, just like a square, all 4 sides are the same, but it doesn't have 4 right angles, so their angles are a little bit different. So that gives you the rhombus. And then lastly, at the bottom, you have your square. And your square is a parallelogram that has all 4 right angles and congruent sides. So what you see here is, in quadrilaterals, you have a parallelogram. A rectangle, rhombus, and square are all examples of parallelograms. So if I ask you what a square is a rectangle, a parallelogram, and a quadrilateral. It's all of those things. So you can follow the chart as it goes all the way down. A rhombus is a parallelogram and a quadrilateral. A trapezoid is just a quadrilateral. And then if you're not used to that word trapezium, it's just a regular shape, 4-sided shape. Okay, so it basically has no parallel sides. You could draw it however you wanted to. But 4 sides, and you make them touch each other. That would be that, and that's just a quadrilateral. So those are the different types we're going to see. You are also going to see something called. So I want to put this on your paper somewhere. Maybe you'll see something called a kite. Okay, and you should probably seen that before. It looks like this diamond shape. It basically looks like a kite. These two sides are the same, and these two sides are the same in a kite. So you may see that as well on your questions. So if you just want to write that in on your quadrilateral sheet, you can draw in a picture of the kite. So you'll paste those in to the quadrilaterals, and that's just a little chart to remember as you're going through what each of them look like, and that will help you when you're doing the classifying quadrilaterals on that the next worksheet. So that's your basic first part. So I'm gonna give you a couple minutes to get that filled in, and then we'll move on to the notes pages. Shows you a little bit about them. So the first one is a rectangle. So if we're looking at a rectangle, it is a parallelogram with 4 right angles. So that's what they talk about with the rectangle. Parallelogram with 4 right angles. Notice where I've marked on this, so you can make the marks. A rectangle has all the properties of a parallelogram, plus it has a couple additional properties. So a couple additional things that it has is a rectangle has 4 right angles. So that was one big key that a rectangle has in this. So the rectangle has 4 right angles, and then also the rectangle's diagonals are congruent. So you've got 2 things there. So the rectangle has 4 right angles, and the diagonals are congruent. So if you see them marked with those little, lines, that shows you that when they cross each other, that those diagonals are congruent, that they're the same. So that will help you see that in the process. Okay. So those are your 2 big things for a rectangle. So again, in a rectangle, it is a parallelogram. It has 4 right angles, and the diagonals are congruent. Okay, so we go to the next, rhombus. A rhombus is a parallelogram, just like a rectangle. It has 4 congruent sides. So in a rectangle, it doesn't have 4 congruent sides, but in a rhombus, it does. So notice those little marks on the outside of rhombus. That shows that all 4 sides are congruent. It also has diagonals. It says that bisect the angles. Bisecting the angles means that the diagonals cut these angles in half. So basically right here and right here, right here and right here, right here and right here, right here and right here. Cuts them in half. So the diagonals bisect the angles. Split it in half. So if you knew this half, you would know this half. If you knew this half, you would know this half. And then the diagonals are perpendicular. So perpendicular just means they make a right angle, 90 degrees. So they're perpendicular to each other. A square is a parallelogram with 4 congruent sides and 4 right angles. I think everybody knew that. It has all the properties of a parallelogram, but it has all the properties of a rectangle and a rhombus. So all the things that we know about a rectangle and a rhombus, all of that is true about a square. So that's how we kind of go through those 3 different shapes. So now we have a couple examples that go with it. The first thing you see here is a rectangle, and we want to solve for x. Now, what do we know about that angle down here in E? So in that rectangle, that bottom angle, what do you know about it in a rectangle? The angle is going to equal what? Anybody? 90, yeah. So the angle is going to equal 90. So I know that both of those things have to add up to 90. So they've got to equal 90. So if you look on example 1, I can zoom in a little bit. But on example 1, we know both of these 2 have to add up to 90. So that's what we're going to do. We're going to say 9x minus 6 plus 2x plus 8 is equal to 90. So we're going to add them up and make sure that they are equal to 90. So in this one, when you add that up, 9x plus 2x is 11x, and then negative 6 plus 8 is positive 2. So I get 11x plus 2 equals 90, and then I'm going to subtract 2, so I get 11x equals 88, and then the last thing I want to do is divide by 11, right? So I get x equals 8. Well, then it says find the measure of each angle, right? So if I know that x equals 8, then I can plug it back in to see what it is. So that one angle, the DEG, the one that's 9x minus 6, I could plug 8 in. 9 times 8 minus 6 is how I would do that. I would just plug it in for x. 9 times 8 minus 6, that gives me 66. So that's how they come up with the 66. And then if I plug 8 into that bottom one, 2 times 8 plus 8 is going to give me 24, right? Because 2 times 8 is 16, and then plus 8 is 24. So that's how they come up with those two answers. You get what x equals, and then you just plug it in to the problem. Okay? So let's look at example 2. Example 2, the middle right there, so you see those lines that are intersecting? The middle where they intersect, we're going to call that E, point E. So right in the middle where those two lines cross each other, right here on my mouse, we're going to call this point E. So it's not labeled on your graph, but you want to call it E right there in the middle. So if A to E is 36, so that means from here to here is 36, this little part right here, this line. If that's 36, and C to E, so the other half, is 2x minus 4, it says solve for x. Well, that's going to be easy because we know that it cuts it in half. So we know that A to E is 36, and we know from C to E is 2x minus 4, so we're just going to set them equal to each other in part A. So we're going to say 2x minus 4 equals 36, and we're able to solve for x. So right there in A, we're going to say 2x minus 4 equals 36, because we know those two parts. And you can draw that on the rectangle if you want to. The 36 is that top half, and the 2x minus 4 is that bottom half. And so if 2x minus 4 equals 36, first thing we want to do is add 4. So now we get 2x equals 40. And then the last thing we want to do is divide by 2. So we get x equals 20. We get x equals 20. Okay? In B, so in part B, if BE equals 6y plus 2 and CE equals 4y plus 6, we want to solve for y. Okay? So if BE is 6y plus 2 and CE is 4y plus 6, we want to solve for y. Now, let me go over here real quick. BE would be from here to here, and CE would be from here to here. Those are still the same size, so we're still able to set them equal to each other. So 6y plus 2 is equal to 4y plus 6. So we know that those are just those little segments. So all we have to do to solve it is set those two equal to each other in part B. And so we subtract 4y, and we get 2y on the left side. We subtract 2 to the right. 6 minus 2 gives us 4. So 2y equals 4. And then finally, we divide by 2. So y equals 2. So that's our final answer. So y equals 2. All right, example 3. Example 3, it looks a little weird. We're going to try to find the measure of all these different angles. Okay, 1, 2, 3, and 4. So let me go over to the triangle to show you. So first of all, we know the first thing that we know is we know that this one here is 58 degrees right here. Now, back in parallelograms, at the beginning of the week, there was this thing called alternate interior angles are congruent. That means alternate interior means the one here and the one alternate from it. So 2. So if this is 58, this one over here has to be 58. Alternate interior. So angle 2 has to be 58. Okay? It has to be. And that's what it tells us there. Angle 2 has to be 58. Now, if you look at angle 1 is in the middle there. It's right here. The angle 1 is this right here. What do you know? What does it say about a rhombus for angle 1? Does anybody know? The angles in the middle have to be what? They got to be 90 because it says they're perpendicular in the middle. So you see that box at the top. So angle 1 is going to have to be 90 degrees. So we already know that angle 1 is 90 because it's in the middle. We know angle 2 is 58 because it's the opposite of those. Okay? So now we got to get angle 3 and angle 4. Now angle 3 is also going to be 58, and the reason why is because it bisects it. So it splits it up. So 2 and 3 are the same. So if you know 2 is 58, you know 3 is 58, right? Okay? Now, in that bottom triangle, you know that angle 1 is 90. So let's look at this bottom triangle over here. You know angle 1 is 90. You know angle 3 is 58. So we want to find angle 4. Well, we know in a triangle, all 3 angles have to add up to be 180. So if they all have to add up to be 180, we could say 180 minus the 2 that we already know. We know 1 is 90. We know the other one's 58. So we can figure out that the missing angle, which is angle 4, has to be 32. So now in that triangle, angles 1, 3, and 4 will all add up to 180. So it's kind of like in these, it's kind of like piecing together a puzzle. You kind of use the information you know and kind of piece together all the other things that you're not really sure of that you're trying to get at the end. Okay, so let's go to example 4. We're going to look at 2, they call it rhombi. So we're going to look at these at a rhombus. I'm going to go to the next page for you here. This is going to be a rhombus. All right, so in a rhombus, we see, first of all, you see this drawing. Now, something that you should know about these in general. So if this is a rhombus, it means all 4 sides are congruent. So in both of these drawings, all 4 sides are the same. So I could set any of them equal to each other, right, to get started. It doesn't matter which one I want to set. Now, I wouldn't want to say 3y equals 5x because what would I solve for? I wouldn't know which one to solve for. But I could say 3y equals 15, or I could say 5x equals 15 because I know the sides are going to be equal to each other. So the first thing that they decided to do is say 4x plus 3 is equal to 15. We know these 2 sides, this one and this one, are equal to each other. We actually could do it with any of them. We could have said 5x equals 15. We could have said 3y equals 15. But they chose to say 4x plus 3 equals 15. Doesn't matter which one you choose. So if you choose 4x plus 3 equals 15, then you'll subtract 3 and divide by 4. And so you get x equals 3. If x equals 3, then that means this side is 15, right? And that means this side is 15 if we plug it in. So that means this side is going to have to be also 15, right? So 3y is going to equal 15. And if 3y equals 15, then you just divide by 3. So y is 5. So if you know already that this side is 15 and this is a rhombus, all of these sides are going to have to equal 15. So if 5x equals 15, you would divide by 5. You get x is 3. That's another way to get it. If this equals 15, you still get x is 3. If this equals 15, you get y is 5. But if you know one side, you automatically know all the other sides. So we know that each side has to be 15. Okay? Now, a little bit trickier in B, you have one side that has an x, and the other sides have y. So we want to set we want to pick two of the sides that have y and set them equal to each other so we can find what y equals. Once we find what y equals, we can figure out how long one of the sides are, and we can then find x. So step 1 in B is to pick two of the sides and set them equal that have y so we can find what y is. So for instance, they did 2y minus 5 equals y minus 1. So 2y minus 5 equals y minus 1. So I subtract y, and I get 2y minus y. That's just 1y. I add 5, I get y equals 4. So if y equals 4, what is one of the sides? Like if you plug in 4 for y, what's the length of one of the sides? Okay. 3, right? Because just 4 minus 1 is 3. You plug it into the other one. 3 times 4 is 12, minus 9 is 3. So all the sides are 3. So we know that all of the sides, all 4 sides, because this looks like a square here, all 4 sides are equal to each other. So if we know all the sides have to equal 3, then we can do the top one. 2x minus 7 is going to have to equal 3. So that's where we're going to get the next one. 2x minus 7 equals 3, right? Because all the sides got to equal 3. So 2x minus 7 equals 3. So we say, you don't need that top part, you just need from right here. So 2x minus 7 equals 3. Then we're going to add 7. That should say x, not y. So 2x equals 10. And so x equals 5. Okay? So make sure that's an x and not a y. So we said 2x minus 7 equals 3. So then add 7. So 2x equals 10. And then divide by 2. So x equals 5. So we got the answer for that. Okay? So again, we're just piecing these together as we go through examples 1, 2, 3, and 4. All right, let's take a look at the trapezoids real quick. There's 2 important things that we have to know in the trapezoid. There's 2 types of trapezoids. There's a regular trapezoid. There's also one called an isosceles trapezoid. It's got the little lines marked on each side. In isosceles trapezoid, we know the 2 legs are congruent. The 2 sides of it are congruent. And in those, we're able to know that opposite angles are, it says supplementary, meaning they add up to 180. So opposite angles are supplementary. So that's very important. So let's look at the first one, which is example 5. And I'm going to zoom in and scroll down. Now, it only gives you angle C is 65, right? But we know that opposite angles are supplementary, so they add up to 180. So if this angle is 65, the one directly across from it is 115. Because 180 minus 65 gives you 115. So we know that they're supplementary. We also know that now if this angle is 65, then this one over here is the same thing, right? Because these sides are the same. So if this angle is 65, and this angle has to be 65. Once we got 65 here, we know opposite sides are supplementary. So it's 115. So again, the opposite angles are supplementary is really important. Supplementary means that they add up to 180. So that's how we know if 165 that the other one is 115. Okay? Let's look at example 6. It's a little bit trickier. It says, what are the values of x and y in this problem, which is kind of like a triangle there. It's an isosceles triangle. So notice what happens here. If you know the if you know the very top one is 32, then we're able to find x and y. So let me zoom out just a little bit. So in that very top one, we are able to find x and y. So if we know that this is 32, then we know that these two angles have to be everything else. Okay? And I would actually say it a little bit differently if I was doing it. If this is one big triangle, this right here. I think this is an easier way of getting it. This is one big triangle. This angle is 32 degrees, right? These two angles, because it's an isosceles triangle, it means that the sides are the same. These two angles have to be equal to each other. They're going to be the same. Okay? So if I know the top angle in a triangle is 32 degrees, how many degrees are in a triangle? 180, right? So I'm going to say 180 minus 32. And that's going to give me 148. Okay? So I know I've got 148 degrees left for these bottom two. And they're the same. So I can just divide it by 2. So I know that each of these bottom two has to be 74 degrees. So this one's got to be 74, and y also has to be 74. Okay? So that's how I'm going to figure that one out. Now, if I know that this angle is 74, opposite angles in here are supplementary. So we said opposite angles in a trapezoid, because that's a little trapezoid down there at the bottom, are supplementary. So they add up to 180. So I can just figure out what x is. X is going to be 180 minus that 74, because they got to be supplementary to each other. So x is going to be 106 degrees. So I'm able to get both. So I started out with a triangle using the whole thing, and then I just was looking at a trapezoid. So that's the only way this can get confusing, is because we start looking at different shapes. Okay, but we're going to try and make it as simple as possible as you go through. So in a triangle, it's got to add up to 180. And so we've got that. And then in a trapezoid, we know that opposite angles are supplementary. So we've got that on there. So that takes care of example 6. So then we move down to example 7, which talks about the mid-segment of a trapezoid. So it's going to be like, if I know the top, the length of the top, the length of the middle, and the length of the bottom, how can I figure that out, what they are? Okay. So let's take a look at example 7. Let's scroll down. And we're going to show you how we go through that. It has the formula. So in example 7, the top and the bottom, you would add in a trapezoid. You're going to add them together and divide by 2 to get the middle. So basically, you're trying to find the middle. If you were doing the middle of 2 points, like back in like math 1 or even before, they said find the midpoint. You add, like if I said the number 6 and 10, find the midpoint. You would say 6 plus 10 divided by 2 is 8. That would be the midpoint. It's kind of what you're doing here. To find that middle line, x plus 2, you're taking the first one, the top line, LM, that's 4x minus 10, plus the bottom line, 8, and dividing by 2 to find the midpoint, that x plus 2. So if we do that, let's see what we do. 4x minus 10 plus 8. Okay? 4x minus 10 plus 8. And then we want to go through, and the first thing we did is it was divided by 2. So we want to get that 2 off the bottom. So to get that 2 off the bottom, we're going to multiply by 2. That cancels it out over here. When you multiply by 2 over here, x times 2 is 2x. 2 times 2 is 4. So that's where they got those numbers from. So we're getting the 2 off the bottom of the fraction. So 4x minus 10 plus 8, that's just 4x minus 2, equals 2x plus 4. Now I'm going to subtract the 2x over. So I've got 2x. I'm going to add the 2 to the other side. So I've got 6. And then I'm going to divide by 2. So x equals 3. So 2x equals 6. Divide by 2. X equals 3. Now, let's think about this, just so you know now that x equals 3. Let's think about it and make sure it actually makes sense. And it does, but let's make sure it does. If x equals 3, 4 times 3 minus 10, that's 12 minus 10. That means this top line is 2. X is 3. 3 plus 2 is 5. So this middle line is 5. And we already know this bottom line is 8. So that makes sense. They go in order. 2 plus 8 is 10. Divided by 2 is 5. So that makes sense that it's the midpoint of them. If you add them together and divide by 2, you should be able to get that middle one. And that's basically what we did. We just did it with algebra. Okay? So on the last one, as I'll scroll over, they're looking at the u try is the same thing. Okay? Just so you see it, but I worked it out. But the last one is the same thing. You take the top and you take the bottom and you add them together. So we're going to say 6x minus 12 plus 18. So we're adding the top and the bottom. Divided by 2 equals the middle, 2x plus 10. And the very first step we did was multiply by 2 to get that 2 off the bottom. And then we just solved it like a regular equation. So that is how you find that midsection that they call on a trapezoid. And that's kind of the last part of quadrilaterals. That was a lot for quadrilaterals, but it's multiple sections, multiple things just put into one. And it's a lot of things that you already knew about these, but now we got to solve them using some algebra. So that's the difference today.